Hey guys, so today we're going to go through Unit 4, Lesson 5 on molar mass and percent composition. There will be a second part to this video that talks about empirical and chemical formulas. So this lesson kind of touches on all of those things. So we're going to just start off talking about molar mass and percent composition, and we're going to work through the exact problems in your lesson that are covered there. So just to give a quick just understanding of what a mole is and what molar mass is, when we say a mole is just a word that means this many things, this many atoms, this many people. If I had 1 mole of chairs, then I would have, I think it's 602 hexillion for how many zeros are there, right? Just like a dozen is 12 and 2 dozen would be 24, or 2 sets of 12, a mole is this many things. Typically, we use it to measure atoms or molecules or any sort of particle because you can't have a mole of people. We only have 7 billion people on Earth. So it's a really, really, really big number. So if 1 mole is 602 hexillion, right, we can write it this way to save ourselves some space. It's the number 6.02 with 23 zeros on the end. So it's 6.02 times 10 to the 23rd. What would 2 moles be? Well, it would just be that times 2, right? It'd be 12.04. If I have 2 moles of atoms, then I have 12.04 times 10 to the 23rd. So I want you to understand what it is so that it's less overwhelming. It's just another word that like connotates a clump of items, just like a ton represents a certain amount, or a ream of paper represents 500 pieces of paper, or a dozen represents 12. A mole represents 602 hexillion things. Molar mass tells you how much a mole of something weighs, okay? And it is found beneath each element on the periodic table, the 12.011, okay? So in other words, 1 mole of carbon would weigh 12.011 grams. What that means is that if you were to measure out 602 hexillion carbon atoms, 602 hexillion, that would be 1 mole. And if you were to weigh them, they would weigh about 12 grams. Okay, that's all that that means. We're really only going to focus on this part of it right here. Okay, so I kind of am just breaking that down right here. 12 eggs is a dozen. If you were to weigh a dozen eggs, I looked it up online, they would weigh about this, right? So not the molar mass, but if we were doing it for a dozen, the molar mass in terms of a dozen would be 681.6. That's how many grams 12 eggs would weigh, right? In the same way, molar mass is telling you how many grams 1 mole of a certain type of element or a certain compound would weigh. So let's practice. Calculate the molar mass of NaCl. Well, NaCl is made up of 2 elements, Na and Cl. So we need to look them up individually and then add them together. And so I recommend using this periodic table. It's on my student resource folder, or you can look one up on your own. We're just going to look up the elements and write down their masses. So sodium's molar mass right here is 22.99. So I'm going to write that down. Now, we can be easier on ourselves, 22.99. If you want to be nice to yourself, we can round it to a whole number. So let's make that 23 grams just to make adding easier. Okay, if it's like really close, like 0.99 or 0.01, don't worry about it. And now we need to find chlorine, which is over here. Chlorine's mass is 35.453. Okay. Actually, sorry, let me share my tab over here. See, chlorine's mass is 35.453. So we're going to write that down. Let's round that to like 35.5, because that when you're just keeping 1 decimal, this number is going to bump it up because it's 5 or higher. And now we're going to add those 2 together. So I'm not the best at adding actually, but I think I should be able to do this. This should be 58.5 grams. So the molar mass is 58.5 grams. And so the units for it are going to be 58.5 grams per mole. This is the answer to one of your questions on there. So just keep in mind, we're going through the problems that are actually on the lesson. This was one of the problems on there. And these are the units for it right here. Okay, let's find the molar mass of H2O. So we have H and we have O, except you see how it says H2O? So that means that there are two H's and only one O. So we need to do 2 times whatever we have for that. And for O, it's just one, H2O, and there's an invisible 1 there. It doesn't need to be written. You just assume it's 1. So now we're going to go back and find H and O on here. So looking over here, I see H. Let's just round that off to 1 because I do not want to add 1.008. And for the purposes of today, we're not a big deal. And you can always do it this way too. Oxygen, let's round that to 16, okay? So 2 times 1, and then just regular 16. So 2 times 1 is 2, and then plus 16. That's going to be 18 grams per mole. That means that if you weigh out 18 grams of water, you have 1 mole of water, which is, remember, 6.02 times 10 to the 23rd. So if you have a kitchen scale right now, you can go weigh out 18 grams of water, and you know roundabout how many molecules of water that you have, 6.02 times 10 to the 23rd. It's super cool. Okay, let's do it for Na2SO4. Now we have 3 elements. We have Na, S, and O. We also have these subscripts. This means that there are going to be 2 sodium, so we need to multiply it times 2. And then how many sulfurs do we have? Well, we just have 1. If you want to write down the 1, you can. It doesn't matter. And then for the oxygens, we actually have 4. Na2SO4, right? So now we know how many, and we can go look up each of these elements. So some of these you might remember. The one, let's see. So there was Na, which I'm going to round that again to 23, 22.99. And then on the right-hand side over here, here is oxygen, 15.999. Let's make that 16. And then for sulfur, let's just make that 32 to make it easier for us. So 23, 32, and 16. I'm going to get my calculator out now for this because I don't want to make any mistakes now. So 2 times 23 is 46. 1 times 32 is 32. And then 16 times 4 is 64. And we need to add all of those together. And I'm just going to do that on my calculator. I get 142 grams per mole. And again, this is problems that are on your lesson. Okay, so now that we know how to do molar mass, real quick, I'm going to teach you how to do percent composition. So to do percent composition, again, you need to find the molar mass. That's step 1. There's kind of 2 steps now. So we got to do step 1, find the molar mass. So let's do that again. So carbon and oxygen, just 1 of each. I remember that oxygen is 16 because we've done that the past few times, but I don't think that we've done carbon yet. So carbon up here, it has a molar mass of 12.011. Let's just make that 12. Again, if your numbers are a little bit off from the lesson, but you get close to the right answer, just choose the answer choice on there that's closest. So 12 plus 16, adding that up, I get 28 grams per mole total. So the percent composition means you find each element and you do the part divided by the whole, part divided by whole times 100%. Okay, so let's do carbon first. You do it for each one. So for carbon, carbon weighed 12 grams and the entire thing weighed 28 grams. So part divided by whole times 100%. So I'm getting 42.85%. Okay, so that could round, actually, I think it rounds to 42.86%. I'm sorry. I get even more numbers than that, but I'm just going to leave it like that. So choose the one closest to that. And then for oxygen, again, it's part divided by whole. The part of oxygen was 16 divided by the whole, which was 28. 16 divided by 28 times 100 is times 100 is 57.14%. These two numbers should add up to be close to 100%. There may be a slight rounding error, which makes it like 100.4 or something if you just round it off a little bit. But for the most part, these should add up to 100%. And so here's our answer there. Let's do it one more time. So we need the molar mass, and then we'll just do part divided by whole of the substances in there. So C2H6. So carbon and hydrogen, okay? There are 2 carbons and 6 hydrogens. If you remember, we just did carbon. Carbon had a molar mass of 12. So that would be 24. And hydrogen has a molar mass of just 1, which would be 6, right? So 24 plus 6. Remember, I'm multiplying it because there are 2 carbons and 6 hydrogens to get a total of 30 grams per mole. Now we need to do the formula, which is part divided by whole times 100%, okay? So we do it for each part, for carbon and for hydrogen. Now, when you do it, our part is going to be after you multiply it, not the 12 now, but the 24, because there are 2 carbons, right? So it's 24 divided by 30. You do it after you've multiplied it by the subscript, and then times 100. 24 divided by 30, and then times 100. I'm getting exactly 80%. So I have a guess in my mind of what the other one should be, right? If this is 80%, what should the other one be? Well, it'll be part, which is 6 divided by whole times 100. 6 divided by 30 times 100 is, guess what? 20%. These two are going to add up to 100. So that is how you do percent composition. If you have any questions on this, please reach out to me and join my classroom, and I will help you out.